So finishing up with the scientific method then, experiments. We said there's always a test group or experimental group and then your control group. And the test group is the one that's getting exposed to the variable. So if we're talking about smoking and lung cancer, the test group would be those who smoke, and the control group would be those who don't smoke, right? Okay. And then data. When we look at data, it should be observable and objective. So there should be some way to see the data. So when you say observable, we should be able to see the lung scans, right, of people to say, yes, they definitely had lung cancer, or the blood work, or the biopsy results. We need observable data that is objective. What does objective versus subjective mean? Yes. Right. Objective is not opinion-based. It's not biased. So objective data would be positive biopsy results as indicated by the lab. They saw cancerous cells in that tissue that was removed from the cancerous lung. Someone saying, oh, I've been coughing up blood, that's subjective data, right? Because were they really coughing up blood? That is a symptom of lung cancer, but can it be caused by other things? Potentially, yes. So that's subjective data. We want to make sure our data is objective. So subjective data is what we see on the internet. We have a lot of people saying, yep, my daughter got the MMR vaccine at age 1, and 2 months later, she was diagnosed with autism. And you think, oh my gosh, for surely that MMR vaccine caused that, because that's what everybody's saying. What they're not saying is I started to see a decline, or my doctor was a little concerned when I brought my baby in for the 10-month checkup, but the doctor said, let's wait until the 1-year mark before we make a diagnosis and do any testing. And that's the reality, is doctors often will do a wait and see kind of thing before they diagnose with autism. So it doesn't mean because they got the MMR vaccine at 1, it caused the autism. It just means at that point is when we start to look a little further. And some people will see a sudden decline. But again, it's not because of the vaccine. The decline could be from a variety of factors where the brain is developing, and when it gets to a certain point around the 1-year mark, that they start to see the decline in social skills and communication. So there's a lot of variables there, a lot of things that we need to control before we make these big statements that vaccines cause autism. Because time and time and time again, all the scientific data that's gone to prove that has failed to prove that. But because of social media, it's out there, and because of subjective data and personal stories that people believe, the rumor is still out there, and people aren't vaccinating their kids, which is very dangerous. If we look at the data of vaccinating versus non-vaccinating, the number of deaths due to non-vaccination or not vaccinating your children is much larger. And we'll maybe, if we get time, talk about that a little bit, because there's huge data from before vaccines came out to after vaccines about the number of deaths related to these illnesses that we've eliminated because of vaccines. And some people are protected because of that, because if everybody around you is vaccinated, are you going to get sick from these vaccine preventable illnesses? Not if nobody's carrying the disease around you, right? But as we spread this rumor around that vaccines are bad for you, more of us are going to be carriers, and these diseases are going to come up again. And these diseases are out there, but they're very rare because most of us are vaccinated, right? But what happens to someone who's on chemotherapy, a child that acquires, cancer at a very young age and can't get their vaccines because their immune system can't handle vaccines? Now, their weakened immune system is at risk because a person next to them said, oh, I don't want to vaccinate because I heard a rumor on Facebook that it's bad for you. Now that person, maybe they'll get like I hear this with influenza. Oh, I don't care if I get influenza because I'm healthy and I'll just get over it. But what about the person that you meet in the grocery store, or you left the influenza virus on the cart, that is getting chemotherapy or has a really poor lung function? If they get influenza, they'll die from it. So sometimes getting these vaccines isn't for you yourself personally, but it's protecting those around you that can't handle these diseases, and it'll take their life. So again, being an informed citizen on some of these issues helps everybody, and that's why a class like general biology is an important class to take. So data should be observable and objective. We should be able to see the data, and that's what you should always say when someone recommends you do or try something. Say, show me the data. right? Just like all the different diets that are out there. Show me the data that this really works, like the ketogenic diet. It's a hugely popular diet. Show me the data that it really works. You know what it does work for? It works for controlling seizures in children. Something about no carbs in the diet helps control seizures in kids. And it does control blood sugar as long as weight is down, but again, it doesn't have any long-term effects. People do lose weight short-term, but it's difficult to maintain and people end up gaining weight back. So that's the data if you dig into it. So anytime we try a diet or an exercise program or a new medicine, we have to look at data. Okay, so there's different types of analysis we can apply to data. And if you took a statistics class, which some of you may have to if you're taking this as a transfer course, there's standard error and probability, statistical significance, p-values. We're not going to analyze that. It's not a statistics class. But those are numbers that tell us how good the data is in how accurate it is explaining some phenomenon. So that's something that you'd have to look at and say, is that good data or is it just data that someone's making a professional opinion? I gave you another example, I think, on Monday about introducing foods to children, right? Did we talk about that on Monday? That's a good example of, you know, what is the significance of that data? Is there really a relationship or not? And then lastly, making a conclusion. So the conclusion will either support the hypothesis or reject a hypothesis. So in your lab reports, you want to always state that in your conclusion. Our hypothesis was correct in that blah, blah, blah. You say what the hypothesis was. Or you say the data did not support the prediction of the hypothesis, therefore we reject the hypothesis based on the data. You always come back to the hypothesis because that's what started your experiment. So if something can be repeated and it's good quality data and research, it'll be posted in a scientific journal because scientific journals are looking to build the knowledge base about certain, you know, observations we have and whatever branch of science we're talking about. So when we look for good scientific data, we want to make sure we're looking in a professional journal, right? And there's online journals, so that's good. But you don't want to look on Susie's homeopathic webpage, right? That's not a scientific or professional journal. Good places to look when you're looking online, it should have a .org ending or a .gov ending. Those usually indicate a little higher level of resources and investigation and research behind those claims. If it's a .com, then that's usually not, you know, really good quality necessarily data. It might be okay, but it's worth looking at it with a little more of a critical eye. I was taking a class one time, and I won't say the name of the website, but it was some government website, and we were going to go look at something for, I think it was a computer class years ago, and they said, go to this .com. Well, they accidentally said .com, and it was some very governmental sounding web page, and they said .com when they meant .gov. If you went to that website of .com, that very normal sounding government website, .com, it took you to a porn site. And this was here at Western. And it was, I took it with my mom because she wanted to learn computer skills. It was all senior citizens, and all of a sudden everybody's like, oh. And the instructor came and looked and said, oh my gosh, .gov, not .com. So I don't know if you've ever noticed that. I was looking on something for my son. It was Steph Curry, shooting form of Steph Curry, because my son's a big basketball player. I typed in shooting form of Steph Curry, and I got a ridiculously grotesque porn site. So be careful. I mean, kids, my son could have been looking for that and been exposed to that. It's terrible. Anyway, so professional journals is where we go to find information. And a good place to look, where I look, is PubMed. You can get abstracts, which again is a summary of experiments and research that has been maybe on a particular treatment for a disease or a particular medicine. It's just PubMed. So there's two types of scientific ways of thinking in terms of what we come to as conclusions for our observations. Theories are accepted explanations for something we observe, but it can't be repeated. So we cannot reproduce that observation that we make. We can't reproduce data that we observe from it because it's impractical. For example, evolution, the origin of life. We can't make new life, right? We don't know exactly how the molecules that make up the cell, how they came together to form the cell. We can't repeat it. So all we can do is look at things we observe today and things we can do in the lab today and say this was what must have happened back then. Like we can look at atmospheres and how our atmosphere is today and how it may have changed and how that may have all contributed to life and how it originated. So we call that a theory then. So evolution is a theory. The cell theory, looking at, again, how the cell develops and how it originated. We can't reproduce the cell in a lab. We have to get it from another cell. All cells come from other cells. That's part of the cell theory. So we can't repeat that. So we can observe, we can perform experiments like I talked about on Monday. We can look at natural selection and see that going on today and say, well, that one must explain how the different species and different types of organisms originate. It must be based on natural selection. We can look at DNA. Now that we have the ability to analyze DNA, we can say, well, this DNA is very closely linked in this organism to this organism, therefore they must be related, or they must have came off the same branch of the evolutionary tree. So we look at things that we can observe, but we can't repeat it in a lab. So it'll always remain a theory, which means it's always subject to change and possibly being rejected or being supported. Scientific principles or laws are something we can repeat over and over and over, and we can prove that it's true. Okay? So the law of gravity. If I drop a ball in a vacuum where there's no air resistance, it's going to drop at 9.8 meters per second per second. It's going to accelerate at that rate. So the longer it drops, the faster it accelerates toward Earth. We can repeat that over and over and over again. It's a law. Newton's laws, right? Every action, there's the equal and opposite reaction. F equals ma, force equals mass times acceleration. So all of those laws, there's three of them. Forget it's F equals ma. One, an object in motion remains in motion, right, until an outside force acts on it. That's the first law. So all these are repeatable, they're accepted, they're not going to change because we can look at the data. So the cell theory, like I said, we can't repeat that. We can't make new cells, but we can take a cell and make another cell from it. We just can't make the first cell. So we have these ideas of how cells originated. Homeostasis, as we know that inside all organisms, there's this state of balance that occurs. How that originated, we don't know. We just see it, that it happens, and we say that this is, homeostasis, and it's a common state of being among all organisms. And like I talked about, evolution is another theory. So it's not something that we can originate and prove in a laboratory. So we're going to talk a lot about biodiversity this semester. Biodiversity, it just refers to the number of different organisms living in an environment. So it depends on what the environment is. We could talk about the world, the biodiversity of the world. We could talk about biodiversity of a country. Within a Myrick Park over by the marsh, we could talk about biodiversity there. We can increase that environment or decrease it and talk about biodiversity. And we can measure the total number and abundance of those different species. Obviously, the more different species and the higher number of each of those species living together, the more biodiverse it is, right? Because you don't want to have just one leopard in an environment in Africa. That's not very biodiverse. You'd want to see a lot of numbers showing that they're able to reproduce and things are looking good, and this environment supports those species. So we have estimated about 15 million different species on Earth. 2 million we've actually recognized and are in the books, so we have a lot more yet to be discovered. And that's why when we destroy tropical rainforests, where we see high levels of biodiversity, how dangerous that is, because we're destroying species we haven't even discovered yet. And there are certain species that we use to our medical advantage, or even just to industrial advantage for eating, right? or certain products are made from certain species, and we'll talk about some of those this semester. So when we destroy habitats and environments, we're killing off species we never even knew existed, and we have missed out on the potential human benefit of those species. So it's very sad. 400 species a day is the estimate of what we lose due to our activities. What's the number one issue? We'll learn this at the very end of the semester, but this is your preview. It's on the test at the very end of the semester. What do you think the number, if you think of all the problems we have, deforestation, pollution, habitat loss, global warming, rising water levels, what do you think is the number one biggest issue? Deforestation leading to habitat loss overall. And our oceans are one of the biggest areas, biggest habitats, biomes that is at risk because of the way we pollute our waterways in the large cities and in different countries too. You go in different countries that don't have the education or the funding, the economy to support good recycling and reusing, their waterways are just atrocious. So as a society, global society, we need to work together in protecting our waterways because it's a big, big problem. Habitat loss is the number one concern across the world for preserving species and maintaining the health of our globe. So, tropical rainforests, coral reef ecosystems are very biodiverse habitats. So when we practice, bad habits like using a lot of plastic, how many of you go to Quick Trip and they say, do you want a bag for that? You say, sure. How long do you use that bag from Quick Trip? Maybe half an hour. And where does it go after that? Garbage, right? Do we need a bag for our 2 items? Not really. Couldn't you set those on your seat and carry them into your house? There'd be one less bag in the garbage. How many of you have a drawer full of these bags from Woodman's and Quick Trip and all that, right? Yeah, I mean, there's just so many of those little bags. Let's make it an effort from now until you guys are old and no longer use bags to not use a bag every time you go to Quick Trip. Tell them, no thanks, I got it, no problem. You don't need all those little plastic bags. My brother works in the administrative offices there, and I told him, I think, is it Walmart or Target? Somebody recycles those bags, that you can bring those bags back and they'll recycle them and reuse them. Great idea. We need to do that across the board. All those stores that have multiple bags, like Woodman's does. I don't know if Woodman's does recycling. Maybe somebody does. I saw it somewhere. Is it Festival that does? Walmart does. Okay, I think Walmart is where I saw it. Yeah, so we can bring other bags to Walmart and recycle them. So if you have a big bundle piled up at home, take them to Walmart next time you go and stuff them in there. Or put them in your car so you remember, right, next time you're at Walmart. Okay, so anyway, we need biodiversity. It's important to us because of food, medicines, raw materials, industrial purposes. We don't want to drain our wetlands. We have natural wetlands. When we drain them, we lose that biodiversity. What do we drain them for? Why do you think we drain wetlands? Why do you want to get rid of that water? What do you think? What's the number one reason for draining wetlands? Here in Wisconsin, I did a research project for that in the DNR. What? Right, right. So for farming. People drain wetlands for farming purposes so they can convert that to cropland and get more money, right? So back in the 90s when I was working for the DNR would give farmers money to put them into reserve and restore them into wetlands. So we would break up the drain tiles and restore those as wetlands. And it was pretty cool. I went around and put my hip waders on and drove out into the middle of these farm fields, and there'd be a wetland right in the middle of the farm field, and there'd be ducks and frogs and all different types of animals and different types of plants, and my job was to document, what different organisms were there. And I had some interesting experiences. One time I was moving slowly through a wetland with my hip waders in the middle of summer, gorgeous day. It's very quiet. And I must have come across like 20 ducks that were just like waiting for me to get close enough, and then they all flew off. and I almost had a heart attack because they were rah, 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 from silence, you know, quietly walking to all these ducks flying over my head. Not good. And then I would get lazy and I would drive my stick shift Ford Escort to the farm field because I didn't feel like walking through the corn. So I would just drive through their little narrow paths. And then one time my car was like smoking and overheating on the highway. So I pulled into a thing, a garage, and the guy opens up the hood, and I had corn husks wrapped all around my engine. He's like, "What have you been doing?" I'm driving through cornfields all summer. So if you drive through corn, look at your engine. It gets up in there and wraps around everything. Okay, so concerns that we have. So some of the concerns environmentally is abuse of our environment, right? So destroying rainforests. Why do we destroy rainforests? Why are people in Africa and Costa Rica cutting down their beautiful, gorgeous, biodiverse rainforests? Yes. Lumber to get the wood, so those tropical forest woods. One tropical forest wood that we see here in the U.S. is mahogany. So if you see something built out of mahogany versus out of oak, and again, informed citizen, right, who took a biology class. So 10 years from now, you're buying furniture for your new home, or maybe just a console for your living room, and the person in the furniture says, "We have this beautiful mahogany, isn't it pretty? Or we have this oak piece, which would you like? Which should you purchase?" Oak, because we have forests here in the U.S. that are managed forests for lumber. So we're not killing tropical forests when we harvest oak, because we have paper mills, or what's the word I'm looking for? What do we call the managed forests? There's a bunch in Black River Falls. My nephew works for one. Stands? Yeah, yeah. And we have these designated forests for industry, for pine and for building and all that. Anyway, mahogany, no, that's a tropical forest wood that's been imported. It's great, it's really hard, but not something you'd want to purchase, because then you're supporting, you know, burning of the tropical rainforest. What else do we use? Why else do people burn tropical forests? Yes. Yes. Right. They're trying to farm it. They're trying to make a living. You can understand, right? If this is the only way you can put food on the table, you're not going to care about global health, right? You're going to say, I care about the health of my child and my spouse. We need to eat. So we're going to take this land that we own and we're going to clear it. But the problem is when they clear it, the grass doesn't grow very well because they put a couple cattle on it. The cattle graze the heck out of that grass and they kill it. It's overgrazed, so now nothing will ever grow in that spot again. Now they move to a new spot. Well, what happens to the old spot? It's dead ground, no longer producing anything. So that's the real danger. So now, again, as an informed citizen, you have to think about these big pictures and say, well, I got to do something about that. So when we look at money, where my money is going in taxes and things, do I want to make sure some of my money is designated for environmental preservation, right? Because we want to think about, we have a responsibility for that, because by keeping that biodiversity in Africa, that helps us here in the United States, because it's producing oxygen into the environment, into the atmosphere, and it's also taking up CO2 from what's being blown out our gas tanks when we're driving our cars. So it keeps the air healthy when the more trees we have. So this cycling of carbon, again, when we burn fossil fuels, and fossil fuels are things like gas and oil. Okay, so gas and oil, petroleum, comes from old fossils deep in the Earth's crust that are under high heat and pressure. They turn into petroleum, and then we take that petroleum, we turn it into oil and gas. Can we replace all those fossils that have been in there for many, many years under heat and pressure? No, because once we take all those fossil fuels out of the Earth's center, or not center, but out of the Earth's crust, what's left? Nothing. So alternative fuels is really important. We can't always rely on oil and gas. Solar energy, that's a good source, right? Wind energy, there's other forms of energy. Because the more carbon dioxide we put in the atmosphere when we burn fossil fuels, the higher the temperatures are across the globe, right? That's what global warming is. Too much carbon buildup, carbon-containing exhaust products in the atmosphere that raise the Earth's temperatures. And when we raise the Earth's temperatures, what happens to the polar ice caps? They melt. And then what happens to water levels? They rise. And what happens to forests that are on the edge and habitats that are on the edge of waterways if the water rises? Yeah, the water creeps over that and kills that habitat on the edge of our waterways. So it's a real problem. And when global temperatures of the water increase, what happens to the organisms living in the water if we increase the water temperatures? They start to die off, because sometimes reproduction is very temperature sensitive. And if we change the water temperatures, organisms can't reproduce. So lots and lots of things to think about when you look at biology and the impact of humans on biodiversity. Do you know what what's on my bucket list to visit, one of the most biodiverse places to visit is? Any idea? Costa Rica. Costa Rica is a small little country surrounded by water, but it's extremely biodiverse. But it is subject to deforestation, tourism, agriculture, all those things that decrease that biodiversity.